Yeah. So next topic is inverter-based switched capacitor circuit. Yeah, there is no amplifier, just inverter. Okay. So for the say, yeah, let's just see. You know the. Let's review just integrator, switch capacitor integrator. Yeah, non-inverting. You see, I have an input here. See, I can sample, let's just say, non-inverting, right? For the non-inverting integrator, I have something like that. And then let's just see, how can I do that? Oh. Just integrate, right? Yeah, I sample this one, and then let's just say this is phi 2, right? C sample, C feedback. Yeah, is this a non-inverting? Let's see. Let's check. Yeah, if I have a plus Q here, minus Q sampled during phi 1, and then with the gain error, I mean with the offset error, and then this minus Q is there. Yeah, it is non-inverting, okay? This is a non-inverting integrator. How can I implement this one using inverters? Yeah, for the inverter, let's just see. It's a little bit complex. See, this inverter thing has a logic threshold. We have to sample logic threshold, okay? Let's see, how can I do that? Oh, yeah. You can compare. I have an input here. So I have a phi 1 there. And then, so I have just phi 1 sampling switch is just there. This is phi 1. And then I have a phi 2 here. Oh, let's see, phi 1 first. Let's take phi 1 first. I have my inverter here. This is VO. This is sampling. This is compensation. I need an extra capacitor. CC. Phi 1. And then this is my feedback capacitor. Oh, yeah. Okay. And then what else? Phi 2. I have phi 2 here. I have a phi 2 there. Yeah, for the during phi 1 base, during phi 1 base, so I have this is real 0. Okay, just this is 0. This is VDD. Okay. Then my I have a Q sampled here. My Q is just CSV in, right? So during phi 1, so how about this voltage? Oops, yeah, here. So this is during phi 1, this is 0, right? So this voltage is, see, I have a negative feedback through CF, okay? So then this goes to logic threshold voltage of inverter. You know, VO, VI curve of this inverter is something like that. Yeah, during phi 1, what's the relation imposed by this CF? You know, during phi 1, CF voltage never changes because input current is 0. Okay, so my VO is just VI, this VO VI, plus this voltage through this CF capacitor. This is only DC, right? If I put this one here, see, this is nothing but this curve. So my input should be located at the logic threshold, okay? By negative feedback. So this is logic threshold voltage. Then this is 0. This CC will sample charge CC times V logic threshold, okay? Yeah, okay. So actually, this current doesn't change. You will see that. This just remains at the logic threshold. Yeah, during by 2 phase, what happens? During by 2 phase, okay, by 2 phase, see, this is connected. So this voltage will remain at the logic threshold by this negative. This voltage will still remain at the logic threshold, and then because of VLT, this voltage still remains at 0 during by 2. Then this is 0, this is 0, so charge will be 0. This minus Q will move there. Okay, it will be added to CF. So then I have an integration operation here. Question? No? How come there's no question? Robert, did you ask a question? No? Then you owe some questions. Ask question. So do you believe this? Huh? Do you understand this part?
Oh, yeah.
Okay. Then I can ask you a question then. All right. During by 2 phase, how come this is 0 volt? By 2. You don't completely understand this pattern. Because during by 2 part, there is a negative feedback by this, right? Say this VI VO characteristic still remains this one, and then this VO is CF. It may be something different. The VO it may be go a little bit. It is too much, so it may be it starts from here to there, still remains here. So this voltage still remains at the logic threshold by negative feedback. So it has some charge VLT here. It keeps CC keeps VLT voltage, so it should be 0. Okay? Do you agree? Nope. Huh? So this charge is completely moved to CF. Okay? Because this voltage is 0. Charge doesn't remain at the CS. Okay, if no question, then let's start here.